shown such dramatic reductions in cost that, under favorable conditions, they are now competing with electricity generated from fossil fuels without government subsidy. The increase in electricity generated from renewables is changing the way power grids are operated. The proliferation of generators powered by renewable energy is leading to a radical reappraisal of the role of traditional integrated electricity utilities that have built their businesses based on interconnected transmission networks supplied by large central, often fossil-fueled generators. As the cost of storing electricity in batteries falls, local generation from renewable energy sources will increase, and the distinction between the producers and consumers of electrical energy will become more and more blurred. The revolution in information and communication technology and the ease with which large volumes of data can now be handled is supporting the development of the smart grid. In the 1950s, it was thought that electricity generated from nuclear energy would be universally attractive and would be too cheap to meter. Nuclear generation remains controversial due to its high costs, concern over safety, and the slow progress that is being made in establishing satisfactory facilities for the disposal of radioactive waste. Environmentalists are divided over whether the advantages that nuclear power offers of constant electricity generation with minimal emissions of greenhouse gases outweighs the risks and environmental impacts. All options for energy supply entail compromise and require hard choices to be made. One desirable course of action is for the richer inhabitants of the world to reduce their consumption of energy. Although not dealt with in this short book in the detail that the topics deserve, energy demand reduction and energy conservation should not be neglected as we consider energy supply systems. In such a rapidly evolving energy landscape, the need for sound understanding to allow informed debate is paramount. However, much of the current discourse on energy systems is not clearly expressed or easily followed. Common examples of the confusion that is found in many otherwise reputable sources of information are not recognizing the difference between energy and power, confusing electrical and thermal energy, and data being quoted in units that do not exist, such as kilowatts per hour. Particular care is needed when comparing costs of energy from different energy systems, as these depend heavily on assumptions and how the calculation is made. The ambition of this book is to assist students and anyone with an interest in energy questions to acquire a basic understanding and vocabulary that will encourage their participation in the crucially important debate of how environmentally acceptable and affordable energy can be provided for all. Thus, the book starts with a review of basic ideas and well-established energy systems before moving on to consider how a future energy system might be configured. In this book, our definition of an energy system includes the primary fuel, conversion system, and means of moving energy to its point of use. Chapter 1: Energy Systems. A reliable and affordable supply of energy is essential for modern life and allows us to cook food and distribute water, as well as to heat and light our homes. Energy is needed in agriculture for cultivation and the manufacture of fertilizer. It is used for transport and to process materials into manufactured goods, while communication and computer systems consume increasing quantities of electrical energy. Thus, it is impossible to conceive of a modern society without reliable and effective systems to provide energy where and when it is needed. Until the 18th century, energy was supplied mainly from animal power or by burning biological materials such as wood. Coal then started to be exploited widely as a source of heat and to fuel the steam engines of the